Hi students, welcome to Alpha C learning program mathematics class. In previous session students, we have discussed about some properties of tangents. Now basing on this one problem also there here. At last we have discussed actually about the locus of feet of perpendiculars drawn from focus on any tangent to a parabola is nothing but tangent at vertex. Okay, we have done that property. So now here students observe the locus of foot of perpendicular drawn from a point given, okay, drawn from a point 1, 2 given to any tangent of this curve, okay, to any tangent of the curve 5 into so on given. So what should be our observation? Nowhere they have mentioned about it is a parabola or some focus like that, anywhere they did not mention, but we have to understand here. So what is actually the standard form? If you observe the 5 value, let us take to the other side, then it is nothing but under root of x minus 1 whole square plus y minus 2 whole square, okay, equal to, what is the value here? 3x plus 4y minus 5 divided by denominator under root of 3 square plus 4 square, that is nothing but here 5. Of course mod will be there. Now this is of what form actually? SP equal to PM type. Then what about focus here? Focus is nothing but 1, 2. Okay, so here locus of x, y is representing a parabola whose focus is nothing but 1, 2. Now this asked here about same kind of point, that is from the point 1, 2 they are asking. Okay, so suppose we have taken here a parabola given, and this is suppose given parabola, and next one this is the tangent drawn to that parabola, and here if you are taking from focus of 1, 2, from focus 1, 2, if you take a foot of perpendicular on tangent, then we know this is exactly on what here? It is nothing but on tangent at vertex. So this line is, this foot of perpendicular is exactly on tangent at vertex. Now they are asking about here equation of locus of feet of perpendiculars. That means here they are asking about indirectly what is equation of tangent at vertex. Okay, so this one, just basing on our property, you can immediately identify what is the equation they are asking. So otherwise we will get a lot of confusion, unnecessary time waste also. But clearly students observe locus of foot of perpendicular from focus, that point whatever it is given, it is nothing but our focus, and on to here any tangent, isn't it, on to any tangent of the parabola, and we know it is nothing but tangent at vertex. So now here how to find tangent at vertex? Of course all of you know, earlier also we have done these model problems, and now here this is equation of which one it is representing? Directrix equation. Therefore here if it is directrix, and the equation of directrix is nothing but 3x plus 4y minus 5 equal to 0. Okay, so this is equation of directrix. And next one is what about the latus rectum of this parabola? Latus rectum, of course all of you remember what is latus rectum? It is a chord perpendicular to axis and passing through focus. Therefore students, this is exactly our latus rectum. And what about latus rectum? It is parallel to again which one here? This directrix and passing through focus. Therefore this equation is 3x plus 4y plus k equal to 0. And what about that k here? It is 3 plus 8, 11. Therefore this is minus 11 is equal to 0. Therefore the equation of latus rectum we got here, it is parallel to the directrix and passing through the point 1, 2. Hence it is 3x plus 4y minus 11 is equal to 0. Understood all of you? Now once you know latus rectum and this directrix, then this tangent at vertex is nothing but a line parallel to these two lines and lying exactly midway between them, and hence this equation is nothing but 3x plus 4y, and this is minus 11 minus 5 minus 16 by 2. Therefore it is minus 8 is 0. Okay, in this way directly you can find here equation of tangent at vertex, which is nothing but the locus of foot of perpendicular drawn from focus onto here any tangent. Okay students, so in this way we got, so this is the line ax plus by plus C1 is 0 and it is Ax plus By plus C2 is 0, then this is Ax plus By plus C1 plus C2 by 2 is 0. So you got this kind of equation, that is our locus. Now students, observe the next one. So this is another property, and already we have done some properties. This is another property. Observe carefully, one of the important properties actually, that is what is the data given in the problem or the property. A and B are given two fixed points, okay. A and B are given two fixed points on a parabola. That means they are given just like 1 comma minus 3, 2 comma 2, like that. Some 2 points given on parabola. And next CB, a moving point on the parabola between A and B, that means within the arc only, okay, between A and B, such that area of triangle ABC here maximum, okay. Then what is the conclusion? Then tangent drawn at C is parallel to the side AB. So this is important condition students. In the maximum case, okay, maximum case, when area of triangle is maximum, in the maximum case, tangent drawn at C, okay, tangent drawn at C is parallel to which one here? Parallel to the line AB, side AB, okay. Now again, this is common here for any kind of parabola. As usual, let us take for the proof, that is nothing but the standard form y square equal to 4ax, okay. So now students, if this is our standard parabola, y square equal to 4ax, and suppose this is the line joining A comma B, okay, A comma B line, I am taking here A as at T1, that is AT1 square comma 2AT1, and B is nothing but here AT2 square comma 2AT2, okay. Now which one we have taken here? Parabola as y square equal to 4ax, right? And now once we have taken this one, they are asking about here a point C is there. How is the point C? It is moving between A and B, between these two, okay, between A and B the point C is there. It can be here or here, anywhere, but it is within the arc AB, okay. Then what about here? Area of triangle is maximum. Suppose C is here students, you can observe C is here exactly. Then you know here area of triangle, the known formula is half base into height, okay. So this one is base, this value is fixed because A and B are fixed points on the parabola. So this value is fixed, and if I write half AB into height, this height if you take, then the maximum area depending on what here? This height, okay. Now if I take C here, this height is small. Again if I take C position here, the height is small. Exactly at one point you take C, where the height is exactly compared to all of them it is more. And if you take here, suppose this is the position of C, here tangent if you take, it will be exactly parallel to which one here? The side AB, okay. So that only they are asking about here. Whenever area of triangle is maximum, many positions are there for the point C, then exactly at one point of C, then you can say here the area of triangle is maximum, okay. So when it will happen? Whenever if you take a tangent at C, that will be at that maximum stage, it will be parallel to here side AB. So how we can prove this kind of result? Of course result is easy only. You can make use of here area of triangle. Already we have done area of triangle concept, okay. When we have done this area of triangle concept in the previous session, while discussing about here the two triangles, one is the points which are on the parabola formed by a triangle, and the other one is just by taking tangents at those points, okay. Then we have compared. Now here also we want to find area. So what is area of triangle ABC? This is equal to, all of you I think remember, it is a square into mod of T1 minus T2 and into T2 minus T3. I am taking this variable point as 80 square comma 280. Therefore I am writing here T2 minus T and into T3 minus T1. Therefore we are writing like this. Okay students, so what is actual formula? delta is half of, you are writing at1 square 2at1 and this is 1, at2 square 2at2, this is 1. Now I am writing this as at square comma 2at and this is equal here 1. Okay, now from this column you take a out, from this column 2a out, then you will get 2a square by 2. Then you got here the known formula, that is 1 1 1 abc and a square b square c square. From that we obtain this result. Okay, now here t1 and t2 are fixed points. Okay, these are fixed, that means you can treat it as a constant. So this is a square into mod of t1 minus t2, right? And now what about this one here? It is mod of, I am taking this is minus t square. Okay, and next this is minus t into, what is this one? Minus tt1 plus tt2. Okay, so this is plus tt1 plus tt2. So t into t1 plus t2, and after that next value you are having here minus t1 t2. So this is the value, students. We got the other value minus t1 t2. So in this way we got here a quadratic value where exactly observe the coefficient of t square is negative. Okay, then for maximum value, okay, what is maximum value? Ax square plus bx plus c. The maximum value is actually it is 4ac minus b square by 4a, 4ac minus b square by 4a occur yet, okay, occur yet x is equal to minus b divided by 2a, okay na? So it is minus b divided by 2a, and in this way here if I take at t equal to, okay, maximum at t equal to, what is that value here? T equal to, which value you are getting here? Minus b by 2a, okay. So minus b by 2a means minus of t1 plus t2 by 2 into how much it is here? 2. This is minus 1. Got it all of you? That implies the value here we substituted in this formula. Therefore you got t1 plus t2 divided by 2. Okay, so this is at t you are getting. Now students, observe here what is slope of line joining a comma b. Okay, what is slope of line joining a comma b? Now we observed this formula in chord joining 2 points. Okay, so you know here slope of AB. What is slope of AB? That is a of t1 comma b of t2 is nothing but 2 divided by t1 plus t2. So this is slope of chord joining t1 t2. And what about slope of tangent at t? Okay, slope of tangent at t. What is this value? Is 1 divided by t. Now observe students, what is this value? At t you got this value. Therefore if I write exactly at t means the slope of tangent at t is how much here? It is nothing but, what is the value? At t is nothing but 1 by t. So if you compare, this is how much here? 2 by t1 plus t2, the reciprocal. That implies, what is the meaning? These two slopes are one and the same. Okay, if here tangent is drawn at c, then tangent drawn at c is parallel to what here? The chord joining 2 points AB. So when this is happening? This is happening exactly when the area is maximum. Okay, so whenever area is maximum, simply you can say here the tangent drawn at the point C is always parallel to the line joining the 2 fixed points A and B on the curve. Okay, so one of the important concept, students. Moreover, for the standard form of parabola, okay, to this standard form, what is that? Maximum area also. Okay, so what is the maximum area also? You can find what is the maximum area here. The maximum area you can say that is nothing but here, what is our formula? 4ac minus b square by 4a. So maximum area you can take here, that is only for this standard form. Okay, this concept you can give here, parallel condition you can give for any kind of parabola, whereas maximum area, whatever formula now we are writing, that is for only to this parabola. Now this is a square into here no change because these are fixed points. mod of t1 minus t2 and into this is our formula 4ac minus b square by 4a. So here 4 into a, what is a value here? Minus 1, and c, that is minus of t1 t2. So directly we can write it is 4 t1 t2, okay, and minus b square t1 plus t2 whole square divided by 4a, that is 4 into minus 1, right? And now what is a plus b whole square minus 4ab, that is a minus b whole square. So a square into mod of t1 minus t2 and into mod of t1 minus t2 whole square, right? And divided by what is the value you got here? 4. So finally students, what is our answer? A square by 4 into mod of t1 minus t2 whole cube. That is formula for maximum area of triangle ABC, okay, of triangle ABC when A and B are two fixed points on it and C is any variable point within the curve, within the arc AB, okay, to the parabola y square equal to 4ax. So you can make use of this formula. And what is the main important concept here? The tangent drawn at C is always parallel to the side AB when the triangle is here taking maximum area, okay. So students, observe this problem. A parabola equation given, y square is 4x standard form and two fixed points are there on the parabola. And now here let C be a point, moving point on parabola between A and B such that area of triangle is maximum. Then the question is, what about here? Coordinates of C. Okay, of course you may think here we can substitute in the parabola, but all four options they give like that only, okay na? So here what about here the coordinates of C, the question, or they may ask here what is the maximum area. Anyways they ask basing on this concept, right? Now how to find here? What is our concept here? In the maximum case here tangent drawn at C is always parallel to which one? The line joining AB. So let us observe here what is here the equation AB. Understand? Our slope. So what is slope of AB students? The slope of AB is nothing but how much it is? This is equal to y2 minus y1. So 10 divided by 5, that is equal to how much? It is equal to 2. Therefore we can say tangent drawn at C, okay, is parallel to which one here? AB, for which case actually the case for maximum area of triangle, okay, maximum area of ABC triangle. So under this case you can define here tangent drawn at C is parallel to the line joining AB. Now you got here slope of AB is 2. Now what about tangent at C slope? Tangent at C slope is nothing but what is our formula here? The slope of tangent at C. This is nothing but here 1 divided by t, okay na? It is 1 by t, and that 1 by t value you got how much? It is 2, okay students. Then what is t value here? It is 1 by 2. Then what about coordinates of C? It is nothing but at square comma 2at. Now what is a value here? It is 1. 4a is 4. So a is 1. Therefore coordinates are 1 by 4 comma this is 2 into a into this value. So it is 1. Okay. So these are coordinates of C you can obtain. Now in the same problem students they may ask about which one actually? The maximum area also. Maximum area means you can take here a square by 4 mod t1 minus t2 whole cube. So what is t1 here? It is 2a, t1 is minus 4, therefore t1 is minus 2. And again 2a, t2 is 6, therefore here t2 value you can write. Okay, then you substitute in the formula a square by 4 into mod t1 minus t2 whole cube. You can obtain again the maximum area also. Okay. Now let us see another property students. So this property is length of tangent. Okay, length of tangent between point of contact P of t and the point where the tangent meets directrix at Q subtends right angle at the focus. Okay, suppose this is again common to all kinds of parabolas whatever properties we are discussing regarding tangent, students, they are for all kinds of parabolas. And for proof only we are using many times y square equal to 4ax. So now also let us take here the parabola y square is 4ax, and this one is here the directrix of that parabola. And now here they are telling the tangent drawn at a point, that is at the point P. So this is the tangent suppose drawn at the point P. So if this is P of t, that is nothing but here at square comma 2at. Okay. So now this is a tangent drawn at P of t, and now next one is this tangent is meeting directrix. Okay, the tangent is meeting directrix. Suppose this is axis of parabola, and now this tangent is meeting directrix at a point. It is nothing but here Q. Okay, it is meeting at the point Q, and you don't know at present the coordinates of Q. And equation of directrix, you know, for this parabola y square equal to 4ax is nothing but what? X equal to minus a. Now what they are telling here, whatever the segment, that means this portion PQ, this segment is always subtending right angle at focus. Okay, if I join this one here and if you join this one here, now this is always right angle. Okay, so this portion whatever you are taking, this is always right angle and it is our focus. So how we can derive this one? Very easy again. This is nothing but here what is equation of tangent. The tangent equation all of you know for this parabola yt equal to x plus at square. So tangent at t is equal to, okay, tangent at t is nothing but yt equal to x plus at square. So this is, students, our tangent. Now this tangent is meeting directrix, that means x is minus a. For q value I am substituting x is minus a. Okay, meets directrix x equal to a minus a. That implies we can write this as yt equal to minus a plus at square. Okay, then what about y value here? At square minus a divided by t. So this is our y value. Hence what about here? Coordinates of q. Okay, so q coordinates, now you got how much is this value? Abscissa is here minus a, and ordinate value you got, it is at square minus a divided by this is t. Okay, so this is our q ordinates. Now observe, students, what is the condition? The condition is here they are telling this portion PQ is subtending right angle at the focus. To that purpose, let us observe what is here slope of SP. Okay, what is slope of SP? Slope of SP is nothing but here 2at divided by at square minus a. Okay, so slope of SP equal to, this is nothing but here the formula if I write, it is 2at divided by the denominator is at square minus a. Okay, so this is our slope of SP. And now what about here slope of SQ? Okay, so slope of SQ if I write, it is nothing but, this is nothing but how much you got? at square minus a divided by t. Okay, at square minus a divided by t. And what about the next value? Divided by t, and what is this value here? Minus a. Okay, so this value is here minus a whole divided by minus a. Now observe here, students, this is our tangent equation. Directrix is x is minus a and x is minus a I substituted here. Therefore you got y value, how much it is? at square minus a by t. And after that here this is a comma 0, and this slope SQ we want, this is minus a, that implies what about this value here? Minus 2a. Okay, so at square minus a by t divided by minus a, that is minus 2a. Now what about here the relation between these two? Okay, so this slope and this slope, students, if you observe, if this is m1 and this is M2, you can understand the product is nothing but how much you got here? Minus 1. Okay, that implies this is 80 square minus A divided by minus 280. So this slope and this slope product, if you observe, you got minus 1, implies SP is perpendicular to SQ. So the right angle you got exactly at S. Therefore students, you can observe here clearly the portion of the tangent between which one it is point of contact and directrix always subtends right angle at the focus. Okay, now relevant problem, how they can ask problem basing on this kind of property. Now observe students here, if tangent at A, okay, that means here they used A, tangent at A to a parabola meets the directrix at B, that means this is our B. If C is focus of parabola, this one is our C, then orthocenter of triangle ABC is on which value, that means on what kind of line of parabola, and what is that orthocenter also. Clearly all of you know, for a right angle triangle, what is the orthocenter? If it is a right angle triangle, the vertex at the right angle is nothing but orthocenter. Okay, now here this is clearly, if we know about this property, okay, if you are aware of this property, clearly you can observe this is the right angle triangle where the right angle is coming exactly at focus. Okay, so what is the orthocenter? The orthocenter is nothing but here focus, and exactly where focus lies, always focus lies on axis of parabola. Okay, therefore the orthocenter is on axis of parabola, moreover it is nothing but focus of that parabola. Okay, therefore here theory kind of bits are very important students in parabola. So one must be aware of whatever properties we have been discussing since last 2 days. Those are all important, which will be useful in this way. Now observe students, tangents are drawn at 3 points on parabola, and if they intersect at 3 points, then orthocenter of this triangle is always on directrix of that parabola. Okay, so observe here carefully, how are the tangents? 3 tangents are taken at 3 points. So let us take the standard parabola. Of course again the property is applicable for any kind of parabola. Now we are using y square is 4ax. Now let us take here tangent, suppose at T1. Okay, this is tangent drawn at T1. And next one more tangent, let us take students here, that is drawn at another point, suppose T2. Okay, and next one tangent is drawn at the next point, suppose it is at T3. Okay, so this is the another tangent drawn at T3. So in this way, if you are taking 3 tangents drawn to a parabola, one is we are taking, this is at suppose here a t1 square comma 2a t1, suppose let us take here a of t1. Okay, and next suppose this one is our b of t2, and next this is our c of t3. So you know the usual notation, a t1 square 2a t1 etc. Now here these 3 tangents, they are intersecting at 3 different points. Okay, so these 3 are intersecting at these 3 different points. Now what is our question here? Whatever the orthocenter of this triangle, this orthocenter is always on directrix. So if this is our directrix here, x is equal to minus a, then orthocenter of this triangle is always on the directrix. Okay, that we have to prove. Whenever you want to prove this is actually a line, x is minus a. Okay, now if at all I want to prove orthocenter is on the directrix, it is sufficient. It is only abscissa value minus a, if you can prove, it is sufficient. Because whatever the point you consider on this line, x is minus a, which is parallel to y-axis, everywhere abscissa remains the same, that is nothing but how much here? Minus a. Okay, so everywhere it is minus a comma some value, minus a comma 2, minus a minus 3, minus a, like this, everywhere abscissa remains same. Therefore it is just sufficient here students to find abscissa value as x is minus a for this value, that is nothing but orthocenter. Okay, then how to prove? Just very small only this also. Now what is here? The point of intersection of tangents drawn at T1 comma T2. You know the formula, point of intersection of tangents drawn at, okay, tangents at T1 comma T2. What is this formula here? This is nothing but a T1 T2 comma a into T1 plus T2. So this is our formula, students. Okay, now suppose I am taking, this is one of the point of intersection of tangents. So this point of intersection where you are getting the tangent drawn at T1 and this is tangent drawn at T2, that implies at this point. So what is this point here? Basically it is nothing but a T1 T2 comma a into T1 plus T2. Okay, so this is our point. Let us take this point as here, suppose P. Okay, students, this is P and another point you take Q and this one is R. So to this triangle, now you are going to find orthocenter. Okay, what is basically orthocenter concept? Orthocenter is nothing but here, if you take altitude from the vertex onto its opposite side, okay, from the vertex onto its opposite side. So this is one altitude, okay, and in the same way another altitude you take, suppose drawn from R, okay, from another vertex onto the opposite one, suppose this is the another altitude you have taken, okay, so this is another altitude if you consider. Now this point of intersection is nothing but our orthocenter, okay. So orthocenter means point of intersection of altitudes. Now let me take here one altitude, thereby just by symmetry we can write the equation of another altitude. So what about here? Equation of one altitude. Now observe, students, this is I am taking through the point P onto QR. Okay, suppose if I take this value as some T here, then PT equation we are finding. So altitude here, this is we are finding through which one here? Altitude. This we are taking from which value? Through P. Okay, through P onto which value here? Onto QR. Okay, students, so onto QR we are taking. Then what is our formula? Y minus y1, that is y minus a into t1 plus t2. Okay, y minus this is y1 a into t1 plus t2. Now what about here? Slope of this altitude. Okay, now this pt, all of you know, it is perpendicular to qr because of altitude. But what is here? Slope of qr, students? This qr is drawn tangent at the point t3. Okay, at the point T3 you have taken this one, and you know clearly slope of tangent at a point T is 1 by T. Therefore slope of QR is nothing but how much here? Slope of QR is nothing but here 1 divided by T3. Okay, because it is drawn at T3. Understand? At T3 you have taken. Therefore slope of QR is nothing but 1 by T3. And hence what about now slope of PT? It is minus T3. Okay, therefore this is equal to minus T3 into x minus AT1 T2. Understood all of you? In this way we wrote about equation of one altitude. Okay, now just by symmetry you can write the other altitude. What about the other altitude? You can observe. So the other altitude is nothing but here I can say clearly y minus, let me take here a into, suppose I am taking T2 plus T3. Okay, na? So T2 plus T3. Then what about this value here? It is minus T1 into x minus AT2 T3. Okay, just by symmetry we are writing suffix 1 to here, 1 to here. So slope is coming in the other kind of suffix. So here also 2, 3 here, 2, 3 here. This is the slope. Now let us here subtract so that we can cancel y, because what is our interest? Our interest is abscissa, whether it is x equal to minus a or not. Therefore let us subtract here, then these two values get cancelled. Now minus AT2 here plus AT2. Okay, you are doing here subtraction. Therefore you got here minus AT2 and here this is plus AT2 get cancelled. Now what is the leftover? Minus AT1, and this side it is how much? This is minus AT3, minus of minus plus AT3, right? And now this side if you observe this value plus a t1, t2, t3, this product, and here also if you take plus a t1, t2, t3, both get cancelled if you do subtraction. And then what is the leftover? X if you take common, is this is minus of minus became plus, so t1 and minus t3, right? But t1 is not t3 because we want a triangle. So t1 is not t3, we want to cancel. So for that purpose I will take here minus a common. Then it is t1 minus t3 x into t1 minus t3. As t1 is not equal to t3, therefore x is how much here? Minus a. Therefore students, clearly you got for ortho center the abscissa value you got minus a, implies clearly the ortho center lies on directrix of whatever parabola we have chosen. What is the parabola we have chosen? Y square is 4ax. To that you got now x is minus a, implies clearly we can observe here the ortho center of triangle formed by the three tangents drawn at 3 points on parabola. They are nothing but here lying on where here? Directrix. Okay. Now let us observe students the second one. What is the second one given here? Tangents to a parabola at the vertex and at any point P. Okay. Tangents to the parabola. So only two tangents are here. What are they here? They are nothing but one is to a parabola drawn at the vertex. Okay. And the other one is that means this is first one tangent drawn at vertex, and this is our a of 0 0. Okay. And next, and at any point P. Okay. And at any point P means what is that value here? Suppose this is the other tangent at any point P. So this is the other tangent. Now this is our point P. Let us take as usual 80 square comma 280. Okay. And this value you know clearly 0 0. And what is the condition? This is meeting tangent at vertex. At what point here? It is meeting at Q. So this is our point Q. Now understand students, then what is the condition they are giving in the problem? If this is axis of parabola and focus is always here a comma 0, then they are telling here SP value. Okay. So this is our SP, and next SQ value. Okay. So this is our SQ value, and next this is our SP. So SA, SQ and SP. Observe the order here. What is the order? Clearly they are giving here. The order is nothing but SA, SQ, SP, or you can take SP, SQ, SA. Okay. These three are always in GP. Now how you can take this one? Very easy here. And what is SP students? It is nothing but focal distance. Focal distance, the word you can use only when the point is on the parabola. Okay. Now what is the formula for focal distance? Mod of x1 plus a. Therefore this focal distance is nothing but mod of a plus at square. Okay. And of course all are in first quadrant, you can use a plus at square. And what about here SA? SA is nothing but how much here? It is A. So writing all known values, first I am writing SP is nothing but A plus at square. And what is SA? SA is nothing but A. Now next interest is here what? SQ. Okay, SQ. What is actually Q students here? It is point of intersection of tangent drawn at the vertex. Okay, tangent drawn at the vertex, and the other one is here which is drawn at any point. Okay, for these two. So what is this equation? Yt equal to x plus at square. So tangent at t I am taking first, that is nothing but yt equal to x plus at square. This is tangent at P. Okay, tangent at P. And now tangent at the vertex, that is nothing but here y axis, so x is 0. This is tangent at vertex. Then yt equal to how much here? At square. That implies y equal to what here? At. Therefore what about here? Q coordinates. The Q coordinates are nothing but 0 comma 80. Okay students, then what about SQ value now? SQ is nothing but here, what is the distance here? A square plus a square t square. So let us take SQ square. Okay, SQ square is nothing but distance formula a square plus a square t square. So if you take a square common here, it is 1 plus t square. Observe now students, what is the product of SP and SA? SP and SA product, if you take, this is the product SP into SA, it is A into this value. So A square into 1 plus t square. Clearly you got the form B square equal to AC, implies the values SA, SQ and SP. These are in which progression? Geometric progression. So which value is Q here? Observe clearly, tangent at the vertex, and what is the other one? Tangent drawn at any point on the parabola. Okay, so these are few properties students which we have discussed, and though they are seems to be here somewhat difficult or anything, but one has to remember these properties. If you remember properties, then problems you can solve very easily. So almost here these properties you have to feed in your mind computer, right?